Thanks everyone who have joined so far. We'll get started. I'll just check if my slides are working. My full name is Ganesh Padmanaban. I work in Guha Tech as a lead SRE. I joined Guha Tech recently as well. Before I was working for a Asia-based startup where I was doing SRE related activities. So for today's topic, I have tried to structure it down by the PFSI framework. What was a problem that we were trying to solve and what solution that we proposed and how we implemented. Maybe I'll walk you through the slides for 10 to 15 minutes, then I'll quickly go through the demo. So there was this startup project where we had an interesting problem to solve. The product was about, let's say if we want to build this mic, right? So whatever the cost that is involved to create this particular product, the manpower, materials, or whatsoever is required, right? So for that product to be out from the production, whatever the cost is involved, that cost can be estimated. So basically this is a SaaS-based product which does the cost engineering of that manufacturing materials or whatsoever it is. Let's say any manufacturing materials of any product. This was actually, people were doing it in Excel for the last a decade or something. And there was one interesting startup who tried to solve that problem by bringing it as a SaaS product. It was a quite complex application as well, involves multiple microservices with around like 200 APIs. So the problem was, we were trying to solve the performance issues. In production systems, we were having a lot of problems in terms of even a single user customer was having issues with a JVM level performance, right? So basically the JVM broke even for a single user, which was maxing out more than a 6 GB of usage. So those were kind of problems that we were trying to solve. So in this case, there were like kind of 50 plus developers who were working on those complex microservices on day-to-day basis. They were trying to do their code check-ins on their feature branches. So there were no ways to do all those performance checks by every developer because they have their own task to do on daily basis, right? So that was a problem that we were trying to solve, and I was only the sole performance engineer asked to automate this problem where we need to test all those microservices and it needs to be fully automated, and the developer will just have a look based on their pipelines whether their code check-ins are passed or not. Basically, when a code gets checked in by a developer on the feature branches, it tries to do the unit integration testing and then functional validations, and then it comes to the performance pipeline. So my task was to combine the performance pipeline into the enterprise grade pipelines, which was part of GitLab. So this developer code check-ins costed us a lot. They were having their own mechanism of testing silos of all those microservices. So what I did is, first we future-proofed the solution, like what problem we are trying to solve and what are tools that I can use, right? So basically the tool ecosystems would be like, we use GitLab, and completely we want to go with the open source, all hands with the open source. That was beneficial as well. So it was GitLab for the CI/CD automation, and we used JMeter. And also, the reason we were trying to solve this problem, even without the involvement of developer, was also one of the asks. And we also want to have the pipeline to be completed within 5 to 10 minutes or 15-minute max. And developer will not look into the entire details of it. They just need a RAG system of communications where they can quickly go and check when the code pipelines are failing. So that's where I started to involve a level of observations to be done automatically without any engineers to be involved in that. So these were the initial performance challenges, and that's where the need for the performance engineering kicks in, right? So developers and product managers, I even had tough discussions on daily basis to understand. Even Sir was also explaining before, a session before, about the non-functional testing, right? You want something to be functional, and just because the opposite is non-functional doesn't mean that you're trying to solve the problem of performance, right? So ideally, I'm also with the same thought as well. So performance is super important when it comes to a complex microservice-driven architectures. So people were in the mindset of shipping through features on every week basis. That was causing us a lot of problems. We have a very simple graph, like how the features are going into the production versus the production incidents. There was a time where the production incident was higher than in the mountain peak when compared to the features. Features were also actually coinciding with the production incidents. So we had to take a pause and we thought this, and most of the things, I would say like 50% of the problems were performance related, right? So that could be not under load also. Believe me, even for one user, as I told earlier, even for one user, JVM broke because it was a very complex calculations and algorithms that is going in background. That was a root cause analysis. Once I got deployed into that project, I started doing the root cause analysis and what problems we were trying to solve. And the major focus, what we thought is, okay, whatever the code check-ins, every developer who wants to do the code check-in on daily basis, let's make sure the performance is getting validated, no matter what, even a small change, right? So that's the reason why we took a step back and go back to the feature development check-ins itself, not even the main branch. So I'll come to the improvements part a bit later, where I give you the demo. So as I said, these were our toolkits where we were using GitLab, JMeter, and for AI, I was using Gemini Pro. In the demo, we will not be able to have a Gemini Pro because of the subscription. But this was something I did 6 months back, but given the days now, you have a lot of things that you can do locally also. And even I tried it with Olalama, but the solution was even more perfect than Gemini. But we targeted to go with Gemini because we had a Pro subscription and we wanted to utilize that. And it was giving what we wanted. For the single user profiling, we were using JVM level tunings by taking up heap dumps and all those things. But we were trying to automate with async profiler to bring that part of the pipeline. So that was pending over there, but yeah. So this is the flow where we do a code check. Once the developer code checks in, the performance CI trigger will kick in, all that is automated, and we will have a result collections from there, right? At the end of the day, this will have dashboards automated in Datadog, and also there was a customized report that I've created at the end, right? So what we were trying to, okay, so there was the problem and we had a solution proposed and we started implementing it, but we need to have some success criteria, right? So if my pipeline is going to run some performance tests, we decided with consensus with the product owners and also from the development team that we cannot measure all, but we want to measure the critical items, right? So that's where we came into three things. That is on the latency. Basically, it's a golden signal. So latency, error rate, and also how the throughput is going to affect, right? So basically, when we run the test, it's going to, the RAG system, which is going to send a Slack notification, is going to measure all those three metrics and send the data to a developer Slack channel. So how it does is based on the RAG status model and HTML report and some CSV analysis. We'll just quickly have a quick demo. Mostly this is the implementation part. Let me zoom a bit. Please feel free to stop me wherever you have some doubts, because this is more of a code walkthrough, and then I'll show you the pipeline, a successful pipeline which was done maybe quite long back, but yeah. So basically this was the GitLab YAML file which touches how things going to work, right? So this is the orchestrator file which is going to help us understand how the implementation is done. As I said, we are using JMeter and we were also using Datadog. So what happens is we also wanted to send our performance metrics or the load test metrics to be sent to the Datadog because we want to have a regression trend, right? So because end of the day, on daily basis, there will be like 50 plus runs that will be going on. based on the developer code check-in. So on the data platform part, we thought like Datadog is already there, why not use that? So I integrated Datadog as well with the JMeter. So whenever this test runs, it also goes into the Datadog metrics. Here, basically I had 2 stages. So this is 30% of what was actually implemented at the client place. But I thought since everything was open source, why not have it open sourced outside as well, right? It's a compressed version, but still it will give you an idea. When you walk out of this session, it will give you an idea of how you can automate things when it gets into developer productivity, right? So basically 2 stages. One is test and analyze. On the test part, we are running a JMeter session. This is a sample script that's going on here. See, with JMeter, we can also combine, it's a performance testing tool where you can also use other frameworks to enhance your testing part. But here I've used only JMeter, nothing more than that. And this will have the scripts that gets picked in from the repo, GitLab repo. And then we are trying to save it into a result file, and that goes into the Artifactory. And then the second part is a key part where a Python framework comes into picture to do all the work that I tried to explain over there. So that's on the analyze part, where what we are trying to do is try to run the Python framework script and take the current test run and then compare it with the baseline numbers. When I say baseline numbers, this will be static file that I'm passing through the repo, which will be like a kind of an SLA, I would say, right? You need something to compare to see whether your success criteria is going to meet or not. So that's where the baseline files comes into picture. And finally, it will generate an HTML report with all the details in terms of how the run was and how it is compared to the baseline results. And then how AI is actually trying to get the prompt and then giving you an automated observations. So basically, as I said, I used Google Gemini. So that's why we are using the API key here. And if we go back to the repo, the other important part is the code. So just have an idea of about like how this was implemented. So basically, we will process the result file through this function, and then we calculate those metrics. For example, in performance, we'll have a lot of other metrics in terms of response times, right? So we calculate all those response times, error rate, throughput. Those are the 3 metrics which I mentioned earlier. If we try to do more, right, so it will be like deviating from what we want to achieve. So that's the reason we stick to 3 metrics at that time. And then there are certain calculations being done on each call level to calculate these metrics. And then there's an error count that gets calculated, and we do a comparison with our baseline file. That is the function that it's trying to do here. And here comes the GenAI analysis, where we push the result files and then give some prompts for the Gemini model to process based on the metrics, success criteria metrics that we want to measure, right? So basically, what we want to do is there should be a 5-line observations which sent to the developer Slack channel about their performance pipeline as part of their code check-ins. So we wanted an observation. So if something fails, what failed and what was the reason from the test report? And then what is breaching the SLA? Basically, we can find if anything is broken in the regression. That was our main motto. So we have given some simple prompts. Here I have given only 2 prompts, but in real time, we can give many, and it works based on what metrics that you're going to pass, right? And then I created a custom HTML report. This was also one of the challenge. So end of the day, people also wanted a Slack notification and also high-level overview. If they think that something has failed as part of the Slack notification, then they go back to the HTML report and then check what has actually failed and what has gone wrong. So here I've created a custom HTML report which gives all those informations with some. We'll have a look on that one, but it just renders the basic details of how the test has gone, comparison, and all those things. And then this Slack thing comes into picture, right? I was talking about some rack status that we'll be sending into the Slack. So there's a Slack integration as well. So if I go back, this is a code walkthrough of the Python script, what it's doing on a stepwise basis. The other one is on the, okay, finally, it gives you an HTML report. Let me go back to the pipeline, or maybe I'll take one successful pipeline which was done a bit long back. Okay, so let's say the test has done with the JMeter execution, and also it has analyzed the test results, right? Sorry, it's still using my mobile Wi-Fi. At the end of the day, if the developer wants to go further from the Slack notification, then it goes to this HTML report, where we give in some key details, right? So it will give you overall metric, try to calculate based on our baseline numbers, which we set it as a static file which gets updated every week. And then it will compare this sample script. So maybe you can ignore in terms of the transaction names. But what it does is it takes the baseline average and says what was done in the current run and what is the difference, how much change. So basically this will give an idea of the delta a developer that he needs to look into, or he or she needs to look into at the end of the day. So that was our main motto as well, because we want to get into, even in the earlier stage, this is more of a, even before doing the actual load test, right? So this is kind of an early performance testing, which is fully automated. So, and then it generates an AI observation. Here, because of this demo script, it does not have the actual data. So what it says, it's based on my prompt. It checks those three criteria of latency, throughput, and error, what has happened in the test, and then it gives the details. If there are any deviations, it will bring in all those details from the test report, and then it captures here. So this is a flow. I'll go back to my slide. So the next step would be like, we want to enhance this as part of the Goa Tech Talk in terms of reliability. Our plan is to have this frameworks integrated to developer pipelines in whatever projects that we want to work in, which will also help the reliability part of the microservices architectures and gives you early decisions about what is happening in terms of the performance topic. So that was one of the plan, and in future, this can be plugged into different tools. Maybe today it was JMeter, tomorrow we can use other different tools in performance, like K6, Artillery. And this pipeline framework will be a kind of a plugin thing where you can use different other tools, and the framework will be already ready to start for you guys. Maybe if we try to open source it, it will be a starter pack where you can just plug and play and then start using any tools to it. At the end of the day, you just need to have one couple of scripts that is part of your performance testing. And then rest everything, the framework is taken care, and then you will get the final results in terms of Slack notification or performance reports, whatsoever it is. That's our future plan. And then I talked about the JVM analysis that was done manually as part of this activity, but we'll be doing it in the future with the async profiler, where that will also be part of the pipeline. So basically, there will be an end-to-end pipeline that we want to have as a framework, which can be a plug and play for anyone who can use it on the go. So I'll stop here and I'll take up questions if you have something. Yeah.
Any work on automating the JMeter scripts part? This is not the new one, but if you wanted to do that kind of a regression way, like it will automatically go and check and update it. Any work on that?
Meaning automating the JMeter script part as well.
The maintenance, basically.
The maintenance part. So it was not covered here, but that is also a plan, because right now, as part of this solution, this has been a topic as always, because end of the day, the scripts keeps changing, and how we can avoid those manual interventions. That was also one of the problem statement that we are working on. In future, that is also one of our thing that we will cover in, and how we will do it is, for example, I'll take Postman, right? End of the day, the JMeter scripts are created based off Postman. I'm not just throwing the solution, but I'm saying like this is how it can be done, and this is how we are planning to do it. So we get a Swagger link and a Postman collection, which can also be automated from Postman to JMeter. There is also a plugin, or you can do that as an automation, which automatically creates a JMeter scripts. See, this is practical when the script complexity is less, okay? Especially if it is an API. But if you want to develop a kind of a web performance script, there's other way as well. You can use web automation using some web automation frameworks. For example, I've used Selenium through web proxy, I don't know, web mob proxy or something, where it captures a HAR file automatically. Basically, it will navigate the user flow using the Selenium web automation, and then it captures the HAR proxy, and then all that I need is a HAR file for the JMeter, and then my JMeter base script would be ready. That would be a web script. And then here comes the challenge, right? So how the scripts can be customized. So we can write in a custom, because Java, JMeter supports Java. So that's where we are also thinking about. These days, nobody is going more into on the web performance testing, right? So mostly into deeper level of APIs. But the answer is, for the web performance would be artillery. There's something called as artillery where you can do browser automation. I'm talking purely open source. There are commercial tools, which personally I don't look into much of a preference because of the cost factors. For web, we are planning to use artillery, where you can do, using TypeScript, you can do the web automation. And for the API, we are planning to do with the Postman.
Is it artillery and JMeter integration, or artillery
Artillery as a separate. Yes, yes. Yeah, see, at the end of the day, on these tools, infrastructure was also one of the problematic challenge. I would say it's a challenge one, right? We were trying, for one of the customers in Switzerland, we were trying to do web load testing. Okay, customers were not interested in API level, because at the end of the day, they want to know what the real user is going to face. So the requirement was, okay, tomorrow there are 100 users logging in through browsers and doing the activities. I want to do a performance test in that fashion, and I don't want to do a backend performance testing. So that was the requirement. So basically what we did, we took the automation suite, which was already available at the client place. So we took that, and then we automated through Grid by simulating 100 browsers at the same time to do the end-to-end flow. But the challenge was the infrastructure, right? You can't, with the browsers, with Chrome, especially Chrome, opening more than 5 to 10 would eat up your RAM, right? Then we got in more VMs. So at the end of the day, we need a lab kind of a setup, which is an infrastructure, which is going to cost us, right? That's the reason why we want to go fully pipeline, right? Artillery supports that. So even in pipeline, you need runners, I understand, but I feel artillery is solving that problem, and especially I'm also moving out of Python to TypeScript, which is much faster, and also it's 10x is what I see, but that's what we want to try as a future solution. Right. Good. Thank you. Thanks all.